Hey everyone, well let's hit section 10.4. Last time we looked at ellipses, this time we're going to look at the hyperbola. So an ellipse, it was the set of points where the sum from two fixed points was constant. Well, a hyperbola is kind of the opposite. It's the set of all points where the difference from two fixed points or the focus points of the foci is constant. So let's kind of look at that. So you can take any point on the hyperbola and measure the two distances to the two focus points. And the focus points sit inside these parabola-like shapes. They're not really parabolas, but they kind of look like it. So if you measure from here to here, that would be R1, and then from that same point to the other focus, that would be R2. So if you chose a different point, we'll just put it over here just for fun. You can measure the distance from here to here, like R3, and then this distance from there to there to that focus, and that would be R4. So according to the definition, if you took R1 and subtracted R2, that would equal R4 minus R3, no matter where you chose the point. If you subtracted that distance, or those two distances, you would always get the same value. So that's what makes it an hyperbola. So just like in an ellipse, a hyperbola can go in one of two directions. They're either going to have these curves that open up to the left or to the right, or curves that are going to open up and down. And you can tell just by looking at the equation which one it's going to be. And it's all about which fraction is negative. So if you notice, it's the same exact type of fraction as it was for the ellipse, just there's one noticeable difference in that you're subtracting instead of adding. So if this was a plus and both fractions were positive, that's an ellipse. But if one of them is negative, you have a hyperbola. So if the negative is attached to the fraction with the y's, then it's going to open to the left and to the right. You can get your center just like you did for the ellipse. Just make each of the parentheses equal to 0. The vertices, they're going to be going left and right. And you get them just the same way as you did for the ellipse. Just add and subtract the A from the center. But hyperbola has these asymptotes in there, and they're not vertical and they're not horizontal. They're actually slanted. And so the asymptotes are going to be figured out by using the equation y equals plus or minus b over a times x minus h plus k. So this is what you usually do to draw the hyperbola. So you would plot the center, so over h and k. And then you're going to do something similar like what you did for the ellipse. You're going to go left and right by the value of a, however far that is. And then you're going to go up and down by the value of b. And then, instead of drawing an oval around them, because that would be an ellipse, what you're going to do is you're going to draw a box with these dashed lines. And what this is going to do, it's going to kind of frame up where the hyperbola is going to go. Because your asymptotes, they're going to go from corner to corner in the box. So this is the equation that would generate them, but this is a much faster way to figure out where they go. And then your hyperbola, since it opens left and right, they're going to sit in between the asymptotes. They'll hit the vertices, but then they're going to hug those slanted asymptotes for the rest of the way. So it looks like, I mean, it's a pretty crazy looking graph, but it's really not that difficult. If you know how to draw an ellipse, you can definitely do these. All right, so for the ones that open up and down, the y fraction is the one that's positive, the x fraction is the one that's negative. Don't necessarily go off of which fraction is first and which one is second, because they could put the minus fraction first and the positive fraction second, just to see if you're paying attention. So if they did it like this, you'd actually be drawing a left and right. So you got to pay attention to which fraction has the minus on it and which one is the positive. The center, same way as before, just h and k. And the vertices, now you're adding and subtracting to the k value of the center. And the asymptotes are going to follow the same exact equation, which is kind of nice. You don't have to switch anything around. So you'd plot them just the same way. Just go to, or get the center going, up and down by b, whatever that value comes out to equal. Left and right both by a. You're going to make that box. And then you can draw in your asymptotes from corner to corner in that box. And now I'm going to draw the hyperbola going up and down. So it'll hug the asymptote, it'll hit that vertice, and then it'll hug the asymptote over there on the right side. And then just draw one underneath. Okay, so that's how you get a hyperbola. So in the next video, we'll look at some specifics, but that is how you do it in general.